the paper Niels Bohr published in 1912, that paper changed the universe forever. The inspiration for this paper came from actually Max Planck. What Max Planck did in 1900, publishing the Planck constant, H equal to NH, E equal to NHF. And Einstein, the Max Planck did not really fully understood what he did, but it took a genius of Einstein to help him understand what he did. And Einstein published the paper in 1905, photoelectric effect. But we're not going to probably cover those ideas, but we're going to touch on these ideas while we are talking about Niels Bohr 1912 paper. Okay, so let's start our conversation. Actually, all it started with the black body radiation and the ultraviolet catastrophe, right? And that led Max Planck to discover what he discovered, that is E equal to NHF. So today our center focus is not A equal to NHF, our center focus is Niels Bohr. Okay, so three people. How many people actually laid the foundation of quantum mechanics? What do you think, Isaac?
I'm going to say like 10.
And Ref?
I think about 7.
Who are they? Who comes first?
Heisenberg.
No,
Heisenberg doesn't come first.
Planck
Max Planck.
comes first,
Sure, that
and
works.
then
Einstein comes second. Bohr comes third, obviously.
Bohr, Heisenberg,
Yeah.
Come fourth.
okay, Dirac,
No, Schrödinger comes before Dirac.
okay, Schrödinger,
Dirac,
Dirac, Pauli,
Pauli.
And that's about it. We don't want to. No,
Robert Oppenheimer.
no. Yeah, if you give everybody credit, then then
I think
yeah, those are the main.
those are the main. So 6.
Gauss, maybe Euler.
Okay, let's go. All right, let's stick to the point. All right, so let's first start with our conversation with Max Planck. Max Planck was born in what year? 1858. What year he changed the universe? What paper did he publish? We're gonna say n is equal to 1, so it looks nice. What year he won the Nobel Prize for this idea? 1918. All right. The second big figure is, of course, Einstein. Albert Einstein was born in, everybody knows, is the most famous person in the universe, so everybody knows his birthday. What year he published his 1905 photoelectric effect, which...
Yeah, I thought he was talking about GR for a second.
Oh yeah, GR is what he's famous for, but GR is not really solely connected with E equal to HF. 1905, his paper on photon. We're not going to say photoelectric effect because we're not going to focus on photoelectric effect today.
See, he's writing everything down, but I'm smart enough to get everything in my head automatically.
That doesn't mean you criticize him.
No. I'm talking
What year he won the Nobel Prize?
1922.
Okay.
1921. Sorry. How can you not know Einstein winning Nobel Prize? That's like, how can you gonna sleep tonight?
I don't know.
Hey, who cares? The history of physics, not real physics. So
No, but this one is embarrassing. I don't know which year he won the Nobel Prize.
I mean, history is as important as the itself.
Okay, then tell me the year Isaac Newton became a fellow of the Royal Society.
Yeah, of course.
Trick question. There was
No. Yeah, he became the president of Royal Society in 1689.
Well, yeah, I actually can't fact check that. So, well, we'll just take his word for it. He could have made up a completely random year and he got after what, 1663.
1663, he didn't even observe apple fall, so he wasn't.
Yeah, I know.
He wasn't famous enough to become.
I know.
So I did some calculation and I completely made it up.
Yeah, you know he died at
because he published the book 1685. So my assumption was he had to publish the book to become the president.
Well, you were probably like 2 years off, while Rifat was 1 year off. How can you not know something so important about the second most important physicist in history? I can't believe it. How are you going to sleep tonight?
I will be suffering.
What?
Yes. Suffering.
What?
For not knowing what year he became the president of, I will be suffering. I'll say, God, forgive me. And since Einstein is himself.
No, you're getting sent to hell. Sorry. You lost your spawn in heaven over Isaac.
All right. Niels Bohr. Is it N-I?
Yes. How could you not know something so fundamental about the third most important physicist than you? No, it's not. Look it up. How could you not know something that important about the third most important physicist in the invention of quantum mechanics? How are you going to sleep tonight?
What year was he born?
1885.
Good.
1885.
He won the Nobel Prize. He published the paper 1912. We're going to focus on his paper 1912. All right. That paper changes everything. However, he stole the idea from Einstein and Planck, but that's what we do.
What? Who's we?
I mean, we use other people's idea to.
Yeah, but like, there's a difference between stealing and using. Was it like academic integrity stealing?
No.
Or was it like using their ideas?
Using their
I
ideas.
think
That's called citation.
What happened
Yes.
was Einstein had the equation and then Bohr looked to the side.
Just because that's what you did with your 2 papers doesn't mean that's what
not what I
everything
did.
is.
That's not what I did.
All right. So what paper? What paper did he publish?
The Bohr model.
The Bohr model.
Oh, I thought he published the Planck model.
No.
Thank you for inviting me.
And what year he won the Nobel Prize for his Bohr
Why do you
model?
have to be one of those annoying people?
22. See, these 3 people did not have to wait forever for their Nobel Prize. Nowadays, you give an idea.
Remember John B. Goodenough?
That
He died.
sucker won the Nobel Prize when he was 98.
Yeah.
For a paper he wrote when he was 38.
Yeah.
And I blame Nobel Committee for that.
Well, he said it was good enough,
It
just
was,
like
it
his
was,
last
it
name.
was the first posthumous Nobel Prize.
Oh.
It wasn't actually
Sorry.
because he didn't die like on the spot.
No, you missed the joke. You missed the joke.
Actually, they did give out one.
Oh my god! Now he's gonna take my.
If you give someone Nobel Prize at 99, I call you giving Nobel Prize at dead people.
Yeah.
Well, he wasn't dead. Actually, he was in pretty good shape
Okay.
until he died at 101. But that's on him.
All right. So let's have start our conversation with hydrogen. When we talk about hydrogen atom, we can think of why there is no proton. I mean, why there is no neutron, Isaac?
I don't know why.
Raf, why there is no neutron?
There
is no repulsive force in the nucleus.
Oh, right. You don't need anything to hold it together.
That's right. So, what is this doing? This multiple, what are you going to call it? Energy level. Energy level N1, energy level N2, energy level N3, energy level N4. I'm just going to call it infinity because we can go forever. Usually the distance from proton nucleus to electron in the fast shell is 5 times 10 raised to 11 meters. That's the usual distance. Anyway,
is that the Bohr radius?
Sure, you can call it. But one thing you know, this is 2D model for what? Hydrogen atom. 1D model for hydrogen atom, according to Bohr, is going to look like this. N1, E1, N2, E2, N3, E3, N4, E4, N infinity, E infinity. Yeah. Okay, so now what is the equation that Bohr gave us? Bohr gave us the equation that En All right, the idea of quantum that he got from Max Planck. Max Planck gave us the idea of quantum. Before Max Planck, we used to think that light is continuous. When there is a hole in the wall and the light enters to the room and you see the light, you don't think you can count. You don't think you see a packet.
I think he sees nothing.
Okay, so now
Nobody laughed. Yeah, we laughed at the pitiful prospect of nobody laughing at your weak insult.
okay, so let's go back there. Yeah, Max Planck did realize that what light comes as a packet, he calls it E equal HF, meaning that there is an N over here. That means well, let's first talk about how many ways the man can create light. Two ways. One is Alessandro Volta's way. Volta's way of creating electricity, meaning that you create a potential difference, create the battery, use the potential difference to flow the current, because moving charges is what we call current, and current goes to filament. The heat will glow it up, current. Another way of lighting up is Faraday's way, by EMF, right? Two ways, but inspiration came from actually how God created light. How do God create light? God created light exactly this way, and that's what the understanding came from these three people. All right, by electron jumping from higher level to lower level is how God creates light, and that's what we're going to try to talk about today. What is the equation that he gave us? The equation that he gave us, negative HCr 1 over n squared. Right. 1 over nf squared minus 1 over ni squared. Okay, good. So now what we're going to do is actually we're going to calculate it. If we do calculate it over here, En is equal to what? Negative HCr 1 over n squared. What is H? Can you engage with the discussion? What is EH?
Constant.
6.63 times 10 raised to negative
34.
JS. What is C?
The speed of light.
3 times 10 raised to 8 meter per second. What is Rydberg constant? Please don't. This is, you're supposed to be modeling, not like. What is? Don't sing while we try to learn something. R is what? 1.097 times 10 raised to 7 meter. So En is, don't forget that 1 over n squared. So En is what? Negative 2.18 times 10 raised to 18 joule. Now for some weird reason, they use what? Electron volt. So negative 2.18 times 10 raised to negative 18 joule. Electron volt over joule. 1 electron volt is how many joule? 1.6 times 10 raised to negative 19. Joule cancel. So this is negative 13.6 electron volt. Okay, now we can safely write when n is 1. Oh, don't forget this is 1 over n squared. So how it is quantized?
Because n is an integer.
N has to be an integer.
N has to be integer, so n has to be either 1 or 2 or 3 and so forth. So electron cannot jump over here.
There is a discrete amount of distance between every single energy level.
Okay, so E1, if you put 1 over here, what do you got? 13.6. If you put 2 over here, minus 3.4.
This is where the zeta of 2 irrationality problem.
Minus 1.96.
Oh, really?
No, I'm just kidding. Because it's 1 over n squared.
Oh, okay. So what about E3?
Minus 1.86.
How do you remember those things?
Just basic physics.
Number 3, number 4?
Minus 0.85.
0.85.
That's what you was thinking.
And the infinity one is probably 0.
Yeah.
Of course, I can tell you, of course, that if you add all of those numbers together, you're gonna get.
It's just a geometric series.
Yeah, no, it's not. You get 22.37.
Okay, so why negative? Why negative?
Because it's a bound electron. The electron is bound to the atom.
Did you just tell
Bound
me that
to the
was
nucleus.
geometric series?
Okay.
So, did you just tell me that's a geometric series?
Other way of thinking of it, in order for electron to escape the nucleus, it has to gain how much energy? 13.6, positive 13.6. Okay, now electron is here. Can you imagine? Electron is on the ground state. When electron is ground state, electron can gain energy. Why?
The electron can,
because it's at the lowest, it cannot go any lower. The only thing it can do is gain
go up.
How do it gain energy?
Photons?
Oh yeah, environment around it. So all the photons jumping down, and all the electrons jumping down, releasing photons, so it can capture energy.
Yeah.
So
in order to go to N2, how much energy it has to capture?
About 10 electrons.
So E1 minus E2 is equal to 10.2.
So let's say it gets exactly 10 electron volts. Does it just stay at E1 anyway because it didn't get that extra?
Yeah, that's right. It doesn't go. That's the Bohr contribution. Before Bohr, it would be like, yeah, it's going to be there. But the Bohr contribution is no, it cannot be there. And it's so easy now, become high school math. But the idea was,
Nobel Prize winning idea.
Yeah, even Nobel Prize, I'm sure Nobel Prize got.
Well, the actual experiments and stuff are definitely on Nobel Prize level. And you still need a college education to understand that. Just the basic ideas can be communicated to a high school.
That's true. Yes. Okay, so now let's see the electron now at higher level. Electron is now N4. Okay, can you imagine electron at N4? If electron is at N4, electron can jump down. Is that right? How many ways it can go to N1?
Well,
Isn't
this a combinatorics problem?
Yeah, tell me how many ways it can go to N1.
Yeah, this is a combinatorics problem.
Yeah, tell me how many ways it can go to N1. 1 way, 2 way, 3 way, 4 way, 5 way, 6 way, or 10 ways?
Wait. I think. Let me see.
Probably 10, but I'd have to add it up.
Yeah.
I'd have to add it up.
Let's see.
Well, there's one way by doing that. One way by doing that. One way by doing that. And 4.
All right, so let's see. From
This is the partition function.
So N4 to
Yeah.
N1, how many ways?
No, can I just write
Yeah.
it down? You can have either N4 to N3 to N2 to N1, N4 to N3 to N1, N4 to N2 to N1, or just N4 to N1. This is actually just the partition function minus 1, because the partition function counts just.
So how many ways it can go?
Well, the partition function of 4 is 5, and 5 minus 1 is 4.
Raf, what is your answer?
Let me see if I get the same thing. 41.
What's missing here?
4, 2, 1, 4, 1. Okay. Yeah, I got the same thing.
Okay, good. All right.
I mean, it's the partition function.
Okay.
Yeah.
All right.
I know more math than you. What is it called? The partition function.
Okay. All right. Now it is at N4. Okay. Can we think? Can you consider that? So En is equal to what? 2.18 times 10 raised to negative 18 joule. Is that right? 1 over N finally squared minus 1 over N initially squared. Let's say it's going to jump to N2. If it does jump to N2, it's going to emit what? A packet. Packet of light. What do we call it? Photon. Photon has no mass. it has a size HF, NHF, and we human perceive that as light. What color do you think it is? Let's find out.
Oh, let's guess.
Yeah, let's guess.
I literally can't guess.
No, I can guess because I'm better than you. So let me see.
I'm gonna guess red.
Okay, no, wait, so red is the longest wavelength line. If it went from N4 to N1, then it would
The
be
difference
something
between
like
red and purple colored light and frequency is so
I-
minuscule that you really can't tell the difference.
I think
just
it
by-
would be either
Wow, you
green.
hear what I just
I
said?
think it would be no, that can't be. I think it will either be orange or yellow.
All right, let's
Possibly
find out.
like pink.
Let's find out 2.18 times 10 raised to negative 18 joule. What is this one? NF.
It's
1 over 16.
One of.
No, it's 1 over
1 over 4 squared.
So this is
No,
initial.
NF
This
is
is
two.
initial. This is final.
Oh, yeah.
Wow, you're stupid.
1 over minus 1 over 16. So En is equal to
3 over 16 times 2.
10 raised to negative 18, 3 over 16.
Which is 4.09 times 10 to the minus 19.
That's joule. Now we gotta go to Max Planck,
Yeah.
and Max Planck gonna help us the way he does all the time. So F is equal to E over H. So E is equal to what?
Wait, 4.09. I'm already doing
4 times 10 raised to negative 19 divided by 6.63 times 10 raised to negative 34.
How can I trust
The frequency should be 6 times
6,
10 raised to 14.
6.16 times 10 to the 14.
Is that right?
6.17 times.
6.2 times 10 raised to 14 hertz. All right. What color is that? Can you go check the internet?
Actually, I have it memorized. 500 nanometers is red light.
Oh,
Yeah, that's way
500,
less dumb.
500 nanometer is not red light. 500 nanometer is blue.
Oh.
500 nanometer is blue. Okay.
Oh,
Wait.
Okay.
What?
But we can go to nanometer from here. Let's check
Yeah.
nanometer.
Then we have to do C divided by N.
Yeah. So lambda is equal to what?
Blue. It's blue.
Is it blue?
Yeah.
Okay.
No.
Wow, you're stupid.
No.
All right. Now let's see. Let's see. You said 500 nanometer, right?
Yeah.
Let's see whether this is 500 nanometer. Isaac, can you sit down? You're blocking the all cameras.
484 nanometers.
Is it?
Yeah, which is in the blue-green range of visible
All right.
light.
So this is either So this is either blue or green.
It's actually blue.
So velocity is lambda times frequency. So what is the lambda? Velocity 3 times 10 raised to 8, and frequency is 6.2 times 10 raised to 14. So lambda is how much?
484.
500 nanometers.
Yeah, 484 nanometers.
484, 500, blah, blah, blah.
So this is blue or what?
Blue-green, also known as turquoise or cyan.
All right, blue green. All right.
Oh, come on, color cyan.
Yeah, cyan is not as fundamental as blue green, but yeah, I call it cyan if that makes you happy. All right. Okay. So, what is your take? Can you share the summary?
Yeah.
Here is the mic. You come over here and then I can. Okay. Here I give you the most powerful thing.
No!
We can try it somewhere else.
Guys, if you see me tomorrow, I might have glasses on.
Okay.
No, you're not making
No, I just want to point at someone. I mean, something. Okay. Okay.
Don't you need to be at least 15 to hold this? Aren't you like 12?
Okay.
Go ahead.
So today we discussed the fundamentals of quantum mechanics, and there were 3 revolutionaries who established quantum mechanics. Let me just remember their names. No, just kidding, just kidding. It was Planck, Einstein, and Bohr. Okay.
What was pink for?
So the Bohr model is as follows.
Memory of the goldfish.
So the Bohr model says that the energy levels of the hydrogen atom are
When did
quantized.
Einstein win the Nobel Prize?
He didn't win it for relativity.
Can you tell me when he won the Nobel Prize?
He gave
What year?
Mileva all the money.
Tell me what year he won the
Okay.
Nobel Prize.
It was 1921.
Oh, wow!
Yeah.
You got it. Congratulations.
Thank you.
Next question, how old was he?
Well, he was born in 1879, so I think he was like 40 or 35. Well, I'm not sure. Let's see, 20 plus 20, 40. Okay, so let's go back to what I'm an expert on. So here's the Bohr model, and the genius idea behind the Bohr model is that the energy levels of hydrogen are quantized. So before the Bohr model, there was the pudding model.
Our physics master's degree candidates can't even subtract, dude. Are we cooked?
Okay, listen. Before the Bohr model, Rutherford had a pudding model of the hydrogen
Are you sure
atom.
that was Rutherford?
Someone had a pudding model. Okay.
Someone else.
Okay.
Next, you're gonna tell me someone invented
Okay.
the wheel.
Let's just keep it to my domain of expertise.
No. Next, you're gonna tell me someone gave birth to you.
Okay. Never mind. Okay. So let's look at the energy levels of hydrogen. The energy levels of hydrogen are given as follows by the Rydberg equation. So minus 13.6, okay, divided by n squared. So that means for the first energy level we have minus 13.6. For the second one we have minus 3.4, and so on and so forth. And for the final
what's the fifth energy level?
For the final energy
Wait,
level.
what's the fifth energy
For the final energy level,
Wait, what's the fifth goddamn Oh shit! I struck a nerve.
So the final
What's the
energy
fifth
level
energy level?
is 0.
Wait,
So
I can't take this.
that means to make the electron escape from the atom, you need to give it plus
What's the
3.6
fifth
electron
goddamn energy level?
of energy.
What's the fifth
Okay?
energy level?
And then the problem
Tell
we
me
look
now. What's the tell me the fifth energy level right now.
Okay, it's less than 0.85.
You gotta be more specific. Give it to 2 decimal places.
Okay. So the next problem we looked at is what happens if the electron jumps from N4 to N2, and we found that the electron will release light that has this much frequency, 6 times 10 to the 14 hertz, which corresponds to 500 nanometer blue light.
Are you sure it's blue light?
So then let me ask you another question. If the electron jumps from n equals 4 to n equals 1, will the light be lower frequency or higher frequency than blue light?
Well, think through this. 1 over nf squared minus 1 over ni squared is going to be way bigger because 1 over nf squared is higher, which means the energy is going to be higher.
I think that's going to be
frequency
ultraviolet.
Frequency is going to be higher, which means that it's going to be shifting more towards violet.
Okay, yeah. So bottom line is it will be more blue shifted.
Who was that? Who invented that? Balmer.
Oh, the Balmer lines. The Balmer lines, the Lyman lines, the Alpha
Are you
lines.
sure it's Balmer?
Okay.
Yeah, Jonas.
Tell me the fifth energy level now.
You can take the calculator.
Sure.
Oh, God.
13.6 divided by 25 is 0.54.
Are you sure 5 squared is 25?
Okay, minus 0.54.
Are you sure?
So Isaac, now you go. You summarize it.
Okay.
I'll give him the mic there.
Okay. Be careful, don't embarrass yourself.
All I'm going to say is that Max Planck and Niels Bohr are 2 of the most underappreciated physicists by the general public.
We are still talking about that.
I said general public. What physicist gets talked about that's alive right now, other than your professor? Name one person talking about it that's not in this family. Okay. So, here we did something pretty simple. Now, it sounds pretty simple today because it's been 100 years, but back when this was invented, this was absolutely revolutionary. This was a discovery made by 2 of the greatest minds in history, even though they were overshadowed by their contemporaries. If Einstein suddenly didn't exist, these 2 would be hailed as the next Newtons. So, thank you to Max Planck and Niels Bohr for inventing possibly, the second greatest atomic model, and the one that we teach to every high schooler across the globe. because it's approximately correct in most situations.
On behalf of both Max Planck and Niels Bohr, I say you will.
I talked to Max Planck yesterday, and he says he does not approve that.
Nah, he died.
No, I talked to him through an Ouija board.
Keep going.
Yeah, that's it.
You didn't explain any of the. Oh, you can. Oh, you don't
What? No,
understand.
you already explained it. Why would I have to?
Yeah, I don't want to give you that pressure. Okay, sit back.